Now let us take one more example of vector space. The example is prove that the set of real numbers r plus dot is a vector space under usual addition and multiplication. We have to check the first 10 properties of being vector space. The first property is closure property. If any xy are element of R, then addition of that xy is also the real number. So first property hold. Second property, for all x, y, z belongs to R, then x plus y plus z, which is equal to x plus y plus z, both are same. So associative property holds. 3, identity element, for all x belongs to R, there exists 0 belongs to R such that x plus 0 is equal to x equal to 0 plus x. The identity element is 0. Therefore, the third property also satisfied by the set of real number. 0 is called the additive identity of R. Inverse element, for every x belongs to R, there exists minus x belongs to R such that x plus minus x is equal to 0, which is equal to minus x plus x. Minus x is called the additive inverse of x in a real number. Property number 5, commutative property. For all xy belongs to R, we have x plus y equal to y plus x. Property number 6, scalar multiplication. For all element k belongs to R and x belongs to R, we have k into x belongs to R. Means the multiplication of two real number is always a real number. Property number 7, distributive property. For all x, y belongs to R and k belongs to R, we have k into x plus y equal to kx plus ky. It is always true. Similarly, the distributive property over scalar, for all x belongs to R and AB belongs to R, we have a plus b into x is equal to ax plus by. Property number 9, for all x belongs to R and AB belongs to R, we have AB into x, which is equal to A into bx. It is also true. And the last property, for all x belongs to R, there is 1 belongs to R such that 1 into x is equal to x. So since all the 10 properties of being vector space are satisfied by the set of real numbers, therefore the set of real number over vector addition plus and scalar multiplication dot is a vector space. Since set of real number is a vector space, therefore all the real numbers are called vectors. Thank you.